For years, Proxima Centauri B, more commonly known as Proxima B, has captivated astronomers and scientists as one of the most promising candidates in the search for life beyond Earth, located just over 4 light-years away and orbiting within the habitable zone of the red dwarf star Proxima Centauri. This exoplanet has drawn considerable attention due to its Earth-like mass and ideal position in what is often referred to as the Goldilocks zone, where conditions could theoretically support the presence of liquid water. Despite an ever-growing body of simulations, spectral analyses, and atmospheric models, none had offered definitive insights until something extraordinary shifted the conversation. The turning point came when Michio Kaku, the respected theoretical physicist and futurist, unveiled a newly captured high-resolution image of Proxima B that sent shockwaves through the global scientific community. The image produced using next-generation deep space observation technologies delivered more than just a clearer look at the terrain. It appeared to provide visual evidence of unnatural structures and anomalies, compelling enough to suggest the possibility of intelligent extraterrestrial life. This remarkable image was the result of a collaborative initiative involving several of Earth's most advanced observatories, with critical data processed through experimental deep-field algorithms from the James Webb Space Telescope. What Kaku presented wasn't another vague spectral reading or speculative artist's concept. It was a crisp, unmistakable capture of Proxima B's rugged landscape in unprecedented detail. But what truly stunned observers wasn't the clarity, it was what appeared within the image. Amid a rocky surface shrouded in a subtle atmospheric haze, there stood formations too geometrically precise to be natural. Rectangular patterns, reflective rows, and what seemed to be a massive structure spanning hundreds of meters glimmered under the faint red sunlight of Proxima Centauri. These formations bore characteristics that defied natural geological processes. They weren't random. They were calculated, aligned, and engineered. Even before the image was made public, analysts, computer scientists, and AI-assisted pattern recognition systems had been tasked with evaluating its contents. Their findings only intensified the intrigue. Symmetry ratios, relational geometries, and architectural patterns echoed the design logic seen in human-made structures: right angles, repeating measurements, and golden ratio alignments. These were not the work of erosion or tectonics. They were deliberate constructions. What followed was even more astonishing. Alongside the structures, thermal imaging revealed heat signatures that hinted at ongoing activity. These weren't geothermal phenomena, but concentrated pulses of heat originating precisely from the symmetrical structures reminiscent of power hubs or technological facilities. These emissions displayed rhythmic patterns, unlike anything produced randomly in nature. Some engineers likened the thermal pulses to alternating current or the coordinated behavior of a planetary-scale computational grid. Kaku, known for his cautious optimism, didn't exaggerate. Yet even he acknowledged that these were the most compelling signs of engineered energy systems humanity had ever observed beyond Earth. Further spectral analysis revealed atmospheric anomalies, trace elements like chlorofluorocarbons, irregular carbon monoxide levels, and isotopic variations that closely mirrored industrial byproducts. Crucially, these chemical markers didn't align with known natural phenomena like volcanic outgassing. Instead, they resembled emissions associated with industrial activity, suggesting that Proxima B may host, or have once hosted, a civilization capable of transforming its environment. The implications were staggering. Capturing such a detailed image was itself a monumental leap in technological capability. It signaled a new era where direct observation, rather than inference from distant measurements, could guide our understanding of distant worlds. But more profound was the question that now gripped the scientific community: if intelligent structures exist on Proxima B, who or what created them? Exoplanetary researchers began speculating about the nature of the civilization responsible. Were these structures signs of a currently active society, or remnants of one that had advanced beyond physical existence, leaving behind autonomous systems that continued to operate? The rhythmic, Recursive behavior of the heat signatures seemed less mechanical and more computational, perhaps even indicative of intelligence embedded in energy itself. Astrobiologists emphasize the magnitude of this shift. Proxima B had always been a hopeful candidate for microbial life, thanks to its position and potential for water. But this was something else entirely. This was not just about finding biological signatures, it was about identifying cultural, architectural, and technological footprints. The very definition of what constitutes life was evolving in real time, expanding to encompass civilization, infrastructure, and communication. Then came one of the most curious aspects of the image, an array located in one quadrant, which reflected electromagnetic signals in a frequency band not associated with natural emissions. When mapped over time, the reflections formed a sequence that matched the Fibonacci pattern, a mathematical concept believed to be universally recognizable. If this alignment was intentional, it could represent an effort to communicate using a shared language of numbers and ratios, an unmistakable sign of intelligent intent. As the discovery rippled outward, it wasn't just the scientific community that responded. Experts from across disciplines, linguists, anthropologists, philosophers, theologians began weighing in. The realization that Earth might not be the sole cradle of intelligent life forced a fundamental reevaluation of humanity's place in the cosmos. The structures on Proxima B didn't merely hint at alien presence. They suggested that intelligent civilizations might be common, existing at various stages of advancement across the universe. Given Proxima B's relative proximity, this planet might simply be the first we've been able to observe, far from the only one. The fact that Michio Kaku was the one to deliver this revelation gave the moment additional gravity. Known for his careful approach to extraordinary claims, his involvement underscored the seriousness of the evidence. He didn't declare definitive proof of alien life, but he urged for a cross-disciplinary investigation rooted in replication and rational inquiry. Beyond the scientific and philosophical implications, the image redefined the future of space exploration. No longer would humanity's ambitions be limited to exploration or colonization alone. Now, interstellar diplomacy entered the equation. If a civilization existed, or still exists, on Proxima B, the challenge of contact moved from science fiction to imminent reality, and with that came a deepened sense of responsibility. Every mission, every satellite, every signal now represented humanity on a broader cosmic stage. The way we presented ourselves, not just technologically but ethically, mattered more than ever. Yet perhaps the most haunting feature of the image was its silence. No radio signals accompanied the thermal pulses. No audible transmissions, only structure, heat, and mathematics. The image appeared to be a monumental artifact of a civilization that was either elusive, beyond our comprehension, or long extinct. That silence, rather than diminishing the discovery, amplified it. It raised the possibility that what had been found wasn't an invitation, but an echo. A remnant preserved across millennia, waiting for another intelligence to recognize its meaning. Historians and archaeologists approached the image like they would ancient ruins, analyzing every line and shadow for cultural significance. Were these temples, machines, cities, or something entirely beyond current human categories? What values, technologies, or philosophies might be encoded in the layout of the site? What kind of civilization could build something that endured time, distance, and decay, still pulsing with purpose across the stars? But for all the wonder, the discovery raised more questions than answers. Was the site a beacon or a warning, a graveyard, or a still operating outpost? Was the civilization that built it aware of Earth? Had they seen our telescopes, our broadcasts, our attempts to scan the stars? These questions remain unresolved, but they've already sparked a global resurgence in exploration. Funding for space research surged almost overnight. Agencies and private organizations alike announced missions to more closely study Proxima B. Artificial intelligence systems were trained to decode potential languages or behaviors of such a civilization. World leaders quietly convened to discuss first contact protocols, For the first time in history, humanity found a shared focus that transcended nations, ideologies, and politics, a distant world that seemed to bear the unmistakable imprint of intelligence, a discovery that has not only changed our understanding of what's out there, but perhaps of who we are and who we might one day meet.